9.3, estimating a population standard deviation. So you'll notice that we've been moving from proportion to mean to standard deviation with these pieces. So paying attention to those instructions in your homework is going to be crucial. All right, so find the critical values here for what we call the chi-square distribution. So if a simple random sample of size n is obtained from a normally distributed population with mean of mu and standard deviation of sigma, then chi-squared equals n minus 1 times s squared divided by sigma squared. And this has chi-squared distribution with n minus 1 degrees of freedom. All right, now, chi-squared distribution is not symmetric. It depends on the degrees of freedom. And as the number of degrees of freedom increases, it becomes more nearly symmetric. We'll see that in just a moment. Now, the values for chi-squared are non-negative, meaning greater than or equal to 0. Okay, so as we can see here, our first one, the blue, dark blue, it is degrees of freedom 2. And then we have the red, the orange, the green, and then finally the purple. And we increase in size. Well, we notice there the purple one, it is more symmetric. It's getting closer to normal on those pieces with them, okay? And so we can start seeing this. So as our degrees of freedom increases, then again, it's going to become a little more symmetric, okay? All right, so let's start by finding the critical values that separate the middle 90% from the 5% area in each tail. Now, we got to be careful in all those pieces. Here it says the middle 90%. That means that we have 10% left, and we divide that in 2 to get 5%. That's our tails on those pieces, okay? And then we want to assume 15 degrees of freedom. Now, remember, if they just tell you n, degrees of freedom is always n minus 1. Here they're telling us directly the degrees of freedom, so we can find those pieces, okay? So this is kind of what we're looking at. That's why it's the 5%. And so we want to look to the right and to the left here of those pieces when we're looking at them, okay? And so we want to be able to look at our table. Now, we're looking for chi-squared of 0.05, and then we're also looking at chi-squared of 0.95 because 1 minus 0.05 is 0.95 on those pieces. So those things are always going to coincide with those, all right? Okay, so we would look at our table. Now again, you have this table in Canvas. So if we go to our home page in Canvas, we scroll down to tables and we see chi table down here. Really, I probably should say chi squared, but try to save some space there so it's not too complicated. Okay. All right, now, just like before, our degrees of freedom is going to run up and down on the side there. So we're looking at those pieces. And so our degrees of freedom runs this way, and then our areas are running this way, okay? So it said 15, so that's going to be important there. And then we said 5%, so 0.05 on this one, and 1 minus 0.95, which is 0.95 for those, okay? And so we just need to go down to where that 15 is. And so that 15 is this bottom one here, and we could also see it there. And so for the 0.95, we're going to get 7.261. That would be our lower. And then our upper would be 24.996 on those. Okay, so we have both those values when we're looking at those pieces. All right, so that's how we read our table. Okay. All right, and so that would be our critical. It'd be, say, the lower critical value there would be the 7.261. Our upper critical value would be 24.996. So it may be advantageous to just find both of them and then put the smaller one in the lower area and the larger one in the greater area, or the higher area. Okay. All right, now what about constructing confidence intervals for these? Okay. All right, so for sigma squared, which is our variance on those, then we have this formula for our lower bound an upper bound. Now there is no shortcut on the calculator. We're going to have to just know these formulas on those. So we'll just kind of work through those pieces, okay? So our lower bound is n minus 1 times s squared, all divided by the chi squared alpha over 2. Okay, and then our upper is pretty much the same, but it's the 1 minus alpha over 2. So that's the difference between the 0.95 and the 0.05 on our table that we just looked at for those things. Okay. All right, now if we need to find just sigma, we take the square root on both sides. And so we have either one of those pieces. So paying attention, are we looking for sigma or are we looking for sigma squared to know whether we need to take the square root or not? Okay. All right, so here we have 12 randomly selected Chevy Corvettes. Okay, and we want to look at their deviation in price on those. Okay, and so we want a 90% confidence interval for the population variance, and then for the standard deviation for those. Okay. All right, so if we go and put those in to L1, we can do our 1 vars, and we would see that our standard deviation is 2,615.19. Okay, and so our variance is our standard deviation squared. So we can just leave it at that. Okay. All right, now because we want a 90% confidence interval, we're looking at 0.90 and we're looking at 0.10 for those. Okay, and we have a degree of freedom of 11 because there were n pieces, or n cars, 12 cars, and we always subtract 1 from that for our degrees of freedom. So that's 11 on those. Okay. All right, so we go to the table there for those. So for the 0.95, we would see that we have at 11 degrees of freedom. So if we go back to our table, so what do we say there again? So 0.95, because we're doing a 90% confidence interval, 0.95 at 11 degrees of freedom. We see right over here that we have 4.575. And then at 0.05 at 11 degrees of freedom, we have 19.675. Okay, and so that's what they have there. So our lower bound, we put in. So we have our 11 for our n, and then our s squared is the 2,615.19 squared, all divided by 19.675. Okay, and so that's a really big number there for those, but that's okay. That's looking at our variance. And then the upper bound is an even bigger number with those. Okay. Now, if we needed to find the standard deviation, the sigma, we take the square root of those to find the lower bound and the upper bound. Okay, and so and you could put that all in at one time, do our square root in the calculator. Okay. Now, our calculator doesn't have a formula for that, and so we just have to do it by hand. And so that means that we are 90% confident that the standard deviation is going to be between 1,955 and 4,055. Okay. All right, so those are the things that you're going to need here in 9.3.